Hello friends, welcome back to the bench. A couple weeks ago we had this Nickelodeon clock for diagnosis, and we diagnosed that the display on it is faulty. Hopefully we're right, because now we have a donor. This is faulty clock. It makes some sounds. As you can see, the display works perfectly, right? The owner, or the person that sold it, one complaint was that the buttons in the back don't do anything, but I think he just didn't know how to actually set it. You need to hold one button and press another one. If you just click them individually, yeah, they don't seem to do much. And the radio doesn't work. And indeed, the radio doesn't seem to work, but mainly because the switch in the back is faulty. It's like physically broken. So the plan is as follows. We're gonna open this one up, remove the display, desolder it, put it in Dave's clock, and hopefully that will remove the problem. If it doesn't, we have quite a pickle, because either way we need to get it fixed. It looks like it's open here. All right, let's get to it. Let's see what we can do. Nope, not the display. All right, it's time to take a break. But here's what we know. The display replacement didn't seem to make any difference. So this display is working. Now, what controls this display is LM8560, which is basically a clock, in one chip. It is supplied by split rail. The clock or the display utilizes 14 pins, and they're arranged as such, if we trust this schematic. The missing lines are still dim. I do notice some low voltages. All right, so this is what we have. Take a look at this. These are our broken lines, right? The dots, these. When I connect the ground over here, this pin, and I go through some of these, right? All of these are broken lines, right? So the display was working, all right? All of these are lines that are broken or were broken. Which means we have a problem on this pin. This is first pin from the left. This pin. We don't have a ground on it. That's why these lines were not working. So now we just need to confirm whether it's the chip that is faulty or we have a passive component here. I was thinking perhaps a diode or something, but oh, there's no but. This could be like we have one diode over here and 100 ohm resistor. I don't see that here in our circuit. Alrighty, so this is our diagnosis. The only thing that stands between this ground that we concluded is faulty is this diode. The resistor, which doesn't seem to exist on this one, but it does on the other one, although the other one works differently and it uses different chip. I concluded that chip is okay, chip is not faulty. It should be this diode. There's just too much voltage drop on this diode, which the meter tells me 0.8. It is kind of high. It should be closer to 0.6 because this is rectifying diode. 0.6, 0.7, 0.5 even. But 0.8 seems in the even larger, higher than 0.8. How do we confirm that? The display is not displaying the lines that were faulty. Now, I don't have a rectifying diode on hand because, well, I just don't. But I have plenty of LEDs. So I'm going to use this LED to do this, and the display is working. 205. Sender, so these were our faulty lines. Alright, so dots in between, and the two would not be displayed. So this is our fault, this diode, which means the display didn't need replacement, so we did that for nothing. On the other hand, was it not needed? If I didn't replace the display, I would never be sure whether the display was working, right? I would not have started testing the display. So as a diagnostic tool, the replacement told us that the display is, we can eliminate the display as a fault. But now all I need to do is just order a diode, rectifying diode. I looked for this chip. It's not available anywhere. Well, anywhere. It's not available in Mauser. Damn, that was painful. But who would have thought, right? Who would have thought it would have been diode? And not to mention, how much time did it take to reverse engineer the circuit? And actually, I got lucky connecting ground here and testing, because I started with this pin, connected the negative and started supplying 3 volts to each pin. And then I noticed that it's all the lines that were broken. So the only common thing for all those lines that are not working is this pin. And that's what pointed me in the right direction. So this is diagnosed, and now we just need to replace the diode, and this should work just fine. A lot of work for nothing as far as the display goes. But, well, this display actually seems like it works a little better. It was in better condition than the one I removed. Slightly better condition. So, and now Dave is gonna have plenty of spare parts in case this breaks again. However, the parts on that one is slightly different, so it's not one to one. That's what makes it more difficult, because I was thinking in this one I'll just check the voltage drop on the diode on this one, but this one doesn't seem to have that diode, which is weird. And I don't know, it kind of seems like it works on a different principle. But the circuit, the what is it, the chip that is over here, which is DMS 3450NL, seems similar, but I think pinout is slightly different. But as far as the display, as we can see, the display works in both. It's the same display. So the circuit needs to work the same way, just the pinout might be different. So, after a trip to the garage, I realized that I have a donor clock, and this should be 1N4007, but I got 4142, but it works just fine. Alright, fellas, I think that'll do for the test. How long has it been? 45 minutes. Looks like it's working. I don't see anything heating up or anything like that. Looks like the whole fault was this little diode here. Which is weird because it doesn't conduct in reverse. It's not shorted. The voltage drop seems a bit high in my view. But there's also other possibility that this diode is not faulty. It's got proper voltage drop on it, but the voltage provided is too low, right? And that would also explain it. That's why I wanted to give it a test, in like long running test, just to make sure that it works consistently. Looks like it does. So I'm gonna stop the video here. I'm not gonna bore you with reassembly, and at the moment I have some other stuff to take care of, so I'm not gonna be reassembling it right this minute. But that seems to be a fix. I hope you enjoyed my struggle with it. Alrighty, thank you guys very much for watching. David, thank you very much for your business and for your trust that you put in me to repair your clock. I hope it'll serve you well. And as soon as I reassemble it, repackage it, it should be on its way back to you tomorrow. Thank you guys, and I shall see you in the next one.